Okay, good morning, everybody. So this is a couple of exercises again from the chapter 25 study guide. Some of the problems that we'll post in the videos are included in the study guide, some are not, just to give you more things to look at eventually. So the first one, the first two actually cover the topic of image formation by mirrors. And these are number 53 and 54 from the end of the chapter. Now, starting with number 53, which I wrote down at the bottom, and just read it out loud. The text of the problem is the following: what is the focal length of a makeup mirror that has a power of 1.5 dioptries? Okay, so let me make sure that we have it here. So the power of a mirror, similar to the power of a lens, in this case is 1.5, and so the 1.5 diopters means 1.5 meters to the minus 1. So I can write it this way: 1.5d is 1.5 over meter. By definition, the focal length is 1 over the power of a lens or of a mirror. Therefore, I just have to invert this power over here, and so it becomes 1 meter over 1.5, which means 0.667 meters. Okay, so this is like 66.7 centimeters. Okay. Number 54 instead states the following: some telephoto cameras use a mirror rather than a lens. What radius of a curvature mirror is needed to replace 800 millimeter focal length telephoto lens? Now remember here that we only talked about spherical mirrors. Okay, so mirror that are being carved by a larger piece of glass with the reflecting coating, and the shape of the whole glass would be like a sphere or a circle. Okay, so those are the only mirrors that we're gonna talk about. We're not talking about parabolic mirrors or anything like that. So in these particular situations, we know that here's the case: the focal point is here, and we want to demonstrate that this focal point is at the distance which is half of the radius. Actually, I wrote the radius there, but that's not correct in this case because this is r and a half. Okay. So again, the definition of the focal length for a spherical mirror is r and a half. We know that the focal length has to be 0.8 meters. The problem gives you 800 millimeters. Okay. And so the radius 2 times the focal length, which is 1.6 meter. Okay. So the radius is actually up here. Okay. And that is the topic of the next problem, which is actually the demonstration of this relationship. And that is problem 62. Which we have on the right board over here. So the right board, the problem number 62 essentially asks us to demonstrate this relationship, that the focal length of a spherical mirror is half of the radius of the mirror. I hope you can read the Greek letters that I wrote over there, but I'm going to go over this with you. So here's your spherical mirror, and here's your focal point here, and the radius of the focal point is up here. So the radius of the mirror is up here, is point C. So the focal length, again, is the distance between the focal point and the point A, which is the point of contact of the mirror. Okay. So